All right, welcome back. So this is another ALEKS topic called using a chemical equation to find moles of product from something, reactants or something like that. So this is a really good ALEKS topic that is sort of the jumping off point for this study of stoichiometry. And in this video, I'm going to do two different versions. This one, which is a little bit easier, and then the next one, which is definitely much more challenging of a stoichiometry problem. So let's go ahead and get started. The first thing we're going to need to do is write a balanced chemical reaction. Anytime we're asked to do a problem like this, we need to start with a balanced chemical reaction. And to write the balanced chemical reaction, that really starts from just writing out what the reactants and the products are, and then sort of figuring out from there, sort of making sure that we are balanced as we go forward with the problem. So this would be my starting point. Just reading the words, ethanol, CH3, CH2OH reacts with oxygen, O2, so that means that those will be the reactants, to form, so now we're going to form our products, water, which is H2O, and acetic acid, which is CH3COOH. And if you ever see anything in one of these that you're not really sure, just look it up. I think that's totally fine at this stage. The main ingredient in vinegar. So that's sort of why, when wine goes bad, that's why it tastes off. It's because it's turned into vinegar, which is sort of gross. But the next thing we want to do is figure out, is this reaction balanced? So step one, write out reactants and products. And then step two, we need to make sure we balance our chemical reaction. That's sort of the whole point here before we can sort of do the multimole ratio. So just looking over this real quick, I've got 2 carbons here, I've got 2 carbons here, I've got 6 total hydrogen atoms, so 3 plus 2 plus 1, and I've got 2 here and then 4 here, so 6 total hydrogen atoms. I've got 3 total oxygens, 3 total oxygens, so this is actually already balanced. So this is a sort of an easier one, we don't need to worry about that. And then now that we have a balanced chemical reaction, now we can do the multimole ratio. So 0.10 moles of water, so it says calculate the moles of ethanol, so that's moles of ethanol, needed to produce 0.1 moles of water, be sure you're yada yada yada. So now we need to use the multimole ratios. So this is the number of moles of water, and I need to figure out how many moles of ethanol. Hopefully you can just sort of see, well, it's a 1-to-1 ratio. So every time we use up 1 mole of this ethanol, we're going to form 1 mole of water. So if I want to form 0.1 moles of water, I'm going to need to use 0.10 moles of ethanol. So I guess that's all we would write as our answer, 0.10 moles. If I wanted to write that out and to sort of show that, I think that it is a good practice, moles of water times 1 mole of ethanol, CH3CH2OH, over 1 mole of water using this multimole ratio from the coefficients. My units will cancel, and then I'll get to our final answer. So this is sort of the more correct way, and sometimes we're going to have to do this, which is going to be the next problem. So let's go ahead and just do that one. So this next problem is definitely a more challenging version. And in this one, it says that our major component of gasoline is octane, C8, make sure we give ourselves enough room here, C8H18. When liquid octane is burned in air, it reacts with oxygen, so plus O2, to produce, so that we're going to have our products, carbon dioxide, which is CO2, plus water vapor, which is H2O. Calculate the moles of water, so moles equals question mark, produced by the reaction of 1.2 moles of oxygen, 1.2 moles of oxygen. So we have our reactants and our products written out, but we need to make sure we balance this chemical reaction. It's not necessarily a 1-to-1 ratio like it was last time. We have to make sure we have to figure out what it is, basically. So when I'm balancing this chemical reaction, there's a number of sort of strategies that you can go through to balance this chemical reaction. This one's definitely much more challenging. I might look at the carbon first and say there's 8 carbons here, there's only 1 carbon here, so I might need to put an 8 here. But I sort of know a trick for these. If I look at this hydrogen, I'm going to need an even number of hydrogens. So if I wanted to balance the hydrogen on this side, I would need to put a 9 here. But if I put a 9 here, then I'm going to have an odd number of oxygens on this side. And I know that I have to have an even number of oxygens. So looking at this, I know that this is going to be a 2 here. Then I'm going to need to put a 16 here. My number of hydrogen, this is going to be an 18. These are really big numbers. This is going to end up being a 25. So I'm not going to spend too much time going over like how I figured that out, but practice that. Practice balancing these chemical reactions. It's necessary, right, to really understand the next step of this process. But this is the proper way to balance this. If we have trouble with this, definitely let me know, and we can sort of work on that. But we need to be able to balance this chemical reaction. Now that I have it balanced, then I can do that multiple ratio thing where I say, well, I have 1.2 moles of O2, and I basically want to convert that into moles of water. 18 moles of water are produced every time I consume 25 moles of O2. My units of moles of O2 will cancel out, and then I'll be left with 0.86, 2 significant digits, 0.86 moles of H2O. So that is my answer that I would put in up here. Yeah, so definitely a little bit more challenging problem. Figuring out what our reactants and products is pretty much the same, but balancing it in this case, and then using that balanced chemical reaction to do our multiple ratio. That's sort of the key aspect of this problem. So hopefully that helps. Let me know if there's any questions about that. Cheers.